Hello, sir. Can we?
Ah,
Okay.
yes, sir.
Oh, great. Okay. So shall we start or shall we
Yes, sir.
wait? Oh, okay. So thank you very much.
Sir, let me just give me 2 minutes.
Oh, sure, please. Take your
Okay.
time. Okay.
Okay. So, good evening, everyone. It is my pleasure to welcome you all for day 3 of the faculty development program on deep learning, intelligent video analytics, and computer vision. Okay. Sponsored by Atal, organized by PA College of Engineering. So let me take a brief moment to introduce our next guest, resource person, that is Dr. Ahmad Jazlan bin Haja Mohideen. He is an assistant professor at the Mechatronics Engineering Department of the Faculty of Engineering, International University, Malaysia, a registered professional engineer with the Board of Engineers, Malaysia, and a member of the Institute of Engineers, Malaysia, with a PhD in Control Systems Engineering from the University of Western Australia. His research interests span across smart materials, renewable energy, biomedical instrumentation and signal processing, control theory, and machine learning. His expertise extends to an industrial attachment with Texas Instruments Malaysia, where he focused on enhancing traceability in legacy machines and forecasting die bond daily output. Okay, with this short introduction, I would like to welcome our Dr. Ahmad Jazlan sir. Welcome, sir. Sir, are you
Yeah.
able to
Okay.
hear me?
Yes, I am. Yeah. Thank you very much for the introduction. So I feel it's a
So now
honor.
I would like to hand over the session to you.
Okay. Thank you very much. So I feel honored to be invited to deliver this just a small sharing of information about transfer learning with all of you. So I'm happy to see we have about 59, 58, sorry, 58 participants in today's session. So as much as possible, I want to try and make this interactive, and also I don't want it to be something very boring for all of you. I hope that you really find this session something that is very engaging, something that's very enlightening, something that will actually increase your understanding and also your interest in machine learning in general. So for my topic for today is actually closely related to some of the other topics that you will be learning later, and also the topic that you did yesterday. So my focus for today is about transfer learning. So I'll just share my entire screen, share, and all right, okay. So I'll go to my slides. This one, okay. Okay, so is the slide clear to you? Is it visible?
No, sir, it is not. Right now, it is visible.
Oh, no, no. Okay, okay, thank you.
Thank you, sir.
Thank you. A bit
Good
of a
evening,
delay.
sir. Welcome.
Thank you. Okay, so what exactly do we mean by transfer learning? Is okay. The by definition, okay, we say it's the improvement of learning in a new task. Okay, what this means? Okay, let's say, for example, if I give you a very brief brief example. So we have a model. Okay, we already have an existing model. We have already trained an existing model, but we are not really happy with the limitations of the model. Maybe the model can only do certain tasks, but it's not able to actually adapt or generalize to actually work in other circumstances or in other situations. So in general, we say transfer learning is the improvement of learning in a new task. So let's say we have already trained a model that can detect, okay, apples. Okay, this model can detect apples. Can we use that model that was already trained to actually detect apples to detect oranges or some other fruits? So there is, we say, the knowledge or the knowledge that was previously learned by the model, it's being transferred or is being adapted to a new situation, or is being actually applied in a new situation. So scientifically, or in computer science, the whole term is referred to as domain adaptation. Okay, so in general, in a nutshell, okay, transfer learning is we are transferring the knowledge from a previously trained model, from a previously trained task, and then this knowledge from that previous task, it's going to be applied or in a new situation. So analogy, if we were to think of an analogy, let's say someone who is very good in riding a bicycle. Okay, he's able to navigate the bicycle, he can ride the bicycle, he can balance when riding the bicycle, he can turn different corners, he can ride at a very fast speed, he can slow down when there is an obstacle in front. So because of the practice or the skills that he has gained when he was involved in cycling, let's say if that same person, he decides to get a motorcycle license. Okay, so the knowledge and the understanding and the skills, maybe understanding of traffic rules, ability to climb hills, for example, ability to balance, and then ability to actually slow down, for example, when an obstacle is in front. All those knowledge that was gained or that was actually learned during cycling, it can actually be transferred to when he is actually riding a motorcycle. So because a motorcycle will also involve riding a motorcycle will also involve balancing. Riding a motorcycle will also involve understanding of traffic rules. And then riding a motorcycle also somewhat is similar. If you're going on a slope, you will need to ride differently, or you'll need to balance differently. You'll need to navigate differently. And for example, riding a motorcycle in heavy traffic, it's quite similar to riding a bicycle in heavy traffic. Okay, so that is one example of transfer learning. All the knowledge that this person has gained uh, while riding a bicycle, some of that knowledge can actually be useful to him when he is riding a motorcycle as well. So it's going to be an entirely different situation. Let's say someone who has never rode a bicycle, someone who has never rode a bicycle before. For example, he was just driving a car or walking or taking public transportation, taking the bus all his life. He has not, or he might need to actually take a longer time to actually ride the motorcycle compared to someone who is already uh, someone who is a professional cyclist, for example, or someone who has been cycling a lot. His learning curve to actually ride a motorcycle is going to be less because he has some knowledge from riding the bicycle. Okay, so before I continue further, okay, so far is this introductory part okay to you? Is I think because we're online, so I'm not sure, like I cannot see your eyes. So far is it okay to you? Does it make sense, the initial concept? 109 students. Okay. All right. Okay. Good. Okay. Can you put a thumbs up? Okay. Or can you put some comment inside the chat if all is good? All right. Okay. These are the lecturers. Any students? Can you put okay? Students, there's thumbs up. All right. Thank you. So that's a kind of feedback for me to know. Okay, are you guys grasping the concept? Okay. So I'll just move along. Okay. So we'll also have some exercises as well in a while about transfer learning. So if we move along, okay, transfer learning, what actually makes transfer learning special is we are not exactly starting from zero. So the standard way in machine learning, let's say you wanted to actually create a very simple machine learning model that can, for example, detect nodules in a chest x-ray. For example, like doctors, for example, if they want to see if someone has lung cancer or if someone has pneumonia, for example, so they're going to send the x-ray to a radiologist, and then the radiologist from his background knowledge, from his experience, he's actually going to be able to see, okay, this chest x-ray, okay, it has a nodule, or this chest x-ray is an indication that this person has pneumonia. Okay, so let's say if we want a computer to take over that task, okay, so we would need lots and lots of images of x-rays with nodules, x-rays with some kind of indication of tumor there, x-rays with examples of pneumonia occurring. So you need lots and lots of those x-rays. But if in the case of transfer learning, the idea is maybe there is some doctor or there are some specialists, there in the medical community, there has been some initial effort such that, okay, they have already gone through like maybe thousands of x-rays, and then they have already taught a computer, or they have already created a model that can actually detect, does someone does someone have pneumonia, does someone have a tumor. Okay, so they have gone through those thousands of x-rays, and they've already, based on the thousands of x-rays that they have looked at, that they have identified having pneumonia, having some kind of tumor. Okay, they have created a model. So rather than another doctor or another team of engineers, another team of computer scientists in Malaysia, for example, rather than starting from scratch, or starting from zero in actually developing a model that can actually detect a tumor or pneumonia, we can actually use a model that was, for example, developed by some researchers in Europe. And then we can actually, on top of their model, we can try and incorporate some of our data, some of our information collected from, for example, patients in Malaysia. Maybe there are some risk factors for getting cancer in Malaysia that are different from the risk factors in Europe. So you're actually, transfer learning is, you're not entirely 100% used depending on their model. But at the same time, you're also not starting from zero. It's a bit of a win-win situation. You're making use of you're making use of the knowledge that has already been captured in a previous model, but you're also infusing some information from your side, some information that the existing model might not have. Okay, so how okay how before transfer learning was actually developed. So transfer learning is quite new as well. It's started in 2007, 2006. So it has not been that long compared to like statistical methods, like all this finding, like prediction, or all this other kind of mode, median, mean. So transfer learning is something that is quite relatively new. So back then, some of the earlier machine learning models. So there are some earlier or very early machine learning models like linear regression, and then there are also some very early machine learning models support vector machine. So these very early machine learning models, how they worked or how they actually operated was, everyone is individually developing their own machine learning model, and then the model that has been trained by someone else, the benefits of that model are not being actually shared by this other person who might benefit from the trained model, and this other person who also might benefit from that trained model. Everyone is actually training their model in silo, individually, without that element of benefiting each other from each other's training. So this concept, before or prior to transfer learning, we say that this is actually learning in isolation. So everyone, okay, I have a computer, I have a model, I have a problem, I solve it on my own, but my solution doesn't benefit another team. And then same goes by vice versa. I have a problem, I have my computing resources, I can train my own machine learning model, but my trained model is not going to benefit another team, or another group of researchers, or another company, another organization. We are all working on the same problem, but we're not sharing our models, or we are not actually sharing our intelligence that has been developed from training a model. So transfer learning is, the whole purpose of transfer learning is we want to break down these barriers. Okay, want to break, basically we have to break down these barriers, and then when we break down these barriers, then you have that element of transfer learning being achieved. Okay, so why exactly is transfer learning being done? Okay, so or what actually led to transfer learning. So if you have noticed machine learning data sets, they are quite large. They are quite large data sets. So if if for example, if for every time we want to develop a machine learning model, we might not have thousands of images of that problem. We might not have millions of images required to actually train a new machine learning model every time. So the idea or the benefit of transfer learning is that if you have limited images or you have limited data about your problem, you can actually use transfer learning in order to solve that problem without having much data. So if I were to summarize, if I go into the chat box, so the key of machine learning is, or the main benefit of transfer learning, if I type transfer learning, we say it actually reduces the need, reduces uh, reduces okay, the need for large data sets. Okay, so this is the main point that, or the main benefit, or the main highlight that I want to convey to you. Okay, why we actually explore transfer learning is that with transfer learning, for example, we don't need millions of images. We don't need thousands of images. If especially if it's a very common problem, there are already we call it pre-trained machine learning models that can solve our problem. But at the same time, it doesn't entirely mean that we can 100% depend on those pre-trained models. There is also the task of us having to collect our own data, so that that pre-trained model is actually customized to solve the problem that we want to solve. So I give an example. Let's say, for example, in India. So in India, like the languages that we have in India. Actually, I'm also so in India. Let's say, for example, you have a model to recognize or to understand Hindi language, for example. So maybe there is some similarity if you want to further develop a model, a machine learning model that can understand Urdu, for example. So there might be some characteristics of the Hindi language. Oh, sorry. I'll put it on the slide. So there might be some okay, thanks. So let's say if I give a example of a machine learning model that can actually understand uh, Hindi language. Okay, so let's say you have already collected a lot of data about Hindi language, and you already have developed a model that can understand Hindi words, for example. So let's say you have another task, or there is another group of researchers. They want to actually develop a model, a machine learning model that can recognize Urdu language, for example. Okay, so from the model that you have trained that can recognize Hindi language, there might be some characteristics or some benefit of the training that can be immediately adapted, or that can benefit, or that can reduce the amount of data needed to train a model that can understand Urdu, because there might be some similarities, there might be some uh, common maybe grammar issues, there might be some similar words with similar meanings between the two languages. So you wouldn't need to actually train, if you already have a machine learning model that can understand Hindi, you wouldn't need to actually train from scratch a machine learning model that can understand Urdu, for example. You can actually benefit, or you can actually use, or you can actually utilize the model that was used to train Hindi in order to understand Urdu. But because of the differences between Hindi and Urdu, you also would need some data or some information about the Urdu language in order to enhance your model, your pre-trained model, which initially could understand Hindi only. It's not entirely that you don't need any additional data. Okay, so before we move along, before we move along, is 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 it clear to you so far, the idea of transfer learning, when we talk about languages, or when we talk about transferring knowledge from one model to another model? Is that clear to you? If you can do a thumbs up, or if you can do type something in the chat box. Sorry. So your lecturers, okay. One, two, okay, thumbs up. All right, thanks. Okay, thank you very much. Okay. So I'll just do a bit more, a bit more talking before we actually do some hands-on. Okay, so talking before we do some more hands-on examples. Okay, so there is sorry, where's my slide? Here, right. Okay, one more. Okay, so there is another advantage. Okay. Because we in transfer learning we need a smaller data set, so transfer learning also increases the speed of our training basically. So in machine learning models, if you have to train, or if you need to actually analyze or learn from thousands of images, then even though you have this very powerful computers, very powerful graphic processing unit, for example, it's going to actually take a very significant amount of time. So transfer learning, because you're not starting from zero, you're not starting from scratch, the training time can be very significantly reduced. Maybe something that would have needed 3 hours, 4 hours, with transfer learning, maybe it just takes about 5 minutes. So this is something, it's considered to be something very valuable in machine learning, because training time is significantly reduced because of the learning, because some of the learning has already been taken place previously, when we had trained the previous model. So training time is significantly reduced. Then on top of that, you don't really need a very large data set. Depending on the problem that you are dealing with, you don't really need a very large data set. Okay, so another example, let's say someone who has played ice hockey before. Okay, so similar case for cycling as well, cycling and motorcycling. So someone who has played hockey, he would understand how to navigate through players, how to bring the ball from one part of the field to another part of the field, how to actually score the ball, how to actually strategize against the keeper, how to make the keeper jump left, for example, but you shoot the ball to the right, for example. So all those skills that were learned by the hockey player, it can be adapted to, if the same hockey player would, if he decided to actually play rather than ice hockey. Okay, let's say this is ice hockey. Let's say he was initially a ice hockey player. He did all the training, and then he actually played many matches, so he has a lot of experience. He's athletic, he's fit, and then he knows how to score goals. He knows how to navigate the ball through this ice hockey ring. Okay, if this same player decides to play actual hockey, he would actually be considered to be a better candidate, or he would actually be considered to be someone who has prior knowledge, or someone who actually has some knowledge from previous training that is going to benefit him when learning, or when actually playing hockey. So this is an example of what we call domain adaptation. Okay, he has a background knowledge of ice hockey. So how can his knowledge of ice hockey actually help him, or to adapt to a new environment, or we call it field hockey. So that's an example of domain adaptation. So some of the skills can be carried forward when he is playing actual hockey. Okay, so those are the two main benefits. You're dealing transfer learning. You don't need as much data as you would in a standard standard machine learning model, and also the amount of data that you need. Okay, also the simulation time, the time required for training is significantly reduced. So there is one exercise I want to do with you today. So there is a tool to actually to be introduced to machine learning. To introduce yourself to transfer learning. Okay, this tool is called Google Teachable Machine. Okay, so um,
We can see only your PPT, sir.
only
Not
PPT. Okay, okay. So share. Okay. Okay. How about now? Is it clear now?
okay, okay, sir.
All right. Thanks. Okay. So this is in order to expose or in order to introduce yourself to transfer learning. There is a tool by Google. It's called Google Teachable Machine. Okay. Google Teachable Machine. So Google Teachable Machine, okay, it's actually making use or utilizing some of the, we say, pre-trained models. You can actually develop your own model. If you have your own set of data, you can actually use Google Teachable Machine to actually develop your own machine learning models, which are based on transfer learning without having to have any programming background. So Google Teachable Machine, we say it's one of those no code platform. So yesterday you were learning about Python. So on top of Python and all the libraries associated with deep learning, machine learning in Python, there are also some tools, we call it no code. So someone who doesn't have a background in programming, for example, even someone who is not from an engineering background, there are some tools to help them create machine learning models by using transfer learning. Okay, so what I want to show you now, what I want to try with you now is, can all of you go to Google? Okay, can you go to Google and then go look for search Google Teachable Machine? So I'll just go now. So on my screen, I'll just search for Google Google Teachable Machine. Okay, can all of you go to Google Teachable Machine? Basically, go to this link or go to this website. So I'm just going to try an exercise with you. I'm going to show you how we can develop by using transfer learning. How can we actually develop our own machine learning model? Okay, let me start. All right, nice. Thank you very much. Okay, so can all of you go to Google Teachable Machine? Teachable Machine. Let's give the link in our chat. Okay, nice. Teachable Machine. Okay, nice. Okay, some of the question. Okay, the question as well. How to choose. All right. Okay, how to choose a pre-trained model that works better for our. Okay, nice. So I'll explain in a bit. Okay, so if you go to okay, so I've also shared basically a Google Drive as well. So inside that Google Drive, okay, I want to do one exercise with you first, more challenging. So right, so on Google Teachable, okay, so make sure you have these two links. So we have Teachable Machine, and then we also, if you can open the Google Drive link I gave you just now, there are some files inside that Google Drive that we are going to use. So there is these two files, cat and dog, and also this pose data set. Okay. Then one of the questions just now was, how do we actually choose which pre-trained model which is best for our data set? So Pre-trained model, there are these basically pre-trained models like GoogleNet, GoogleNet, AlexNet, ResNet, MobileNet. So there are actually these we call it pre-trained models that have already been trained on millions of images. So Google Teachable Machine is actually one of the tools that makes use, is actually utilizing one of those some of those pre-trained models to actually build our own model. So if you go to teachable machine, so there's three examples. You can either create by using transfer learning. You can either create a model that can recognize images. So you need your webcam, and also later on, in order to try this example, I also need you to use your phone as well. Okay, so make sure you have your phone, and also make sure your webcam is working. So you can teachable engine, teachable machine. You can also recognize sounds as well. Okay, like what is this person saying? Is it something positive or is it something negative as well? We call it sentiment analysis. That can be done by Google Teachable Machine as well. And then we have another example in Teachable Machine. This is actually pose recognition. Okay, is someone showing a thumbs up? Is someone showing thumbs down? Is someone actually showing a peace sign, for example? So all of that can be actually done by using this teachable machine. So if just to briefly answer one of the questions just now, how do we actually choose what we call a pre-trained model that is suitable for our application? So this, for example, this particular example, post project, okay, post example, this particular teachable machine with Google, actually, it uses something called a POSNet. So POSENET. So POSNet is actually a pre-trained model that is customized, or actually it's built to actually on a large data set which deals with pose estimation. Okay, so it's a very large data set that is focused on posing different poses, for example. So it's different from GoogleNet. GoogleNet is another pre-trained model that actually has been trained on like millions of images, but different categories. So it can recognize a dog, it can recognize cat, it can recognize a car. But this particular pose project, it uses PoseNet, POSENET. The elements of the images or the images that were used to actually develop this pre-trained model is mostly poses. So this would be a most, if our task involve pose estimation, then this using PoseNet will be the most one of the most suitable pre-trained model. Okay, so if you can go to image project, so you'll have to log in first. If you can go to image project, okay, so you'll see that there are two options. Okay, so the first option is, we say it's a standard image model. Okay, it's a standard image model. So this standard image model, this is meant for models that are going to run on a computer. Okay, so we also have embedded image model. Okay, go back. So embedded image model is meant for machine learning models that are going to run on microcontrollers, that are going to run on embedded systems. So in our next session after me, we are actually going to cover about embedded systems as well. So if, for example, at the end of the day, you are building some kind of robot that needs to recognize surrounding environment, then this would be actually be the better option for you, or this would be the option for you to actually train your machine learning model, because these trained machine learning models are meant to be running on embedded systems. So this standard image model, these are meant to run on computers. So for example, if you want to develop, for example, a face recognition system using your webcam on your computer, then this standard image model will be the ideal model for you to develop. Okay. So, okay. So before we move along, before we actually try an example, so far, is it okay for you? If you can thumbs up or say something in the chat box before we try it. All right, nice. My thumbs up. Thank you very much. Okay, so I want to show. Okay, we'll just do a quick cat dog example before we try something more complicated. So if you have any questions, you can type as well, and then I'll answer in a bit. Okay, so if you go here, teachable machine, sorry, yeah, get started, fine. So I'll just make a quick model to recognize a cat and a dog. So standard image model. Okay. So teachable machine, we have, let's say we have two classes. The first class consists of images of cats. The second class consists of images of dogs. So either you can take photos using your webcam or you can upload. So in my case, I'm going to upload. So if you can save these files somewhere in your computer, in your C drive, or in your together with all the other lecture notes. Okay, I'm going to just upload the images that I have onto this teachable machine. Okay, standard image model. Okay, upload. So I'm going for the first class. I'm going to upload 5 images of cats. So you can import from your Google Drive as well. Okay, so I have these 5 images of cats, 5 only, not many. So I'm going to try and see. So I don't know whether it'll work or not. So I'm going to try and see whether this teachable engine, at the end of the day, when I take my phone and then I Google an image of a cat, and then I point the image of the cat to my camera, can it detect that as a cat based on this very small data set? Okay, so it's actually going to highly depend on the pre-trained model that was used to develop this teachable machine. So I'll just upload all these 5 images of the cat. I'll put it here. Okay, so 6. So I have 6 images of a cat. So I'm going to go to the second class for dogs. And then I have images of dogs saved somewhere here, small data set, dogs. Okay, so I have 2, 3, 4, 5, 6 images of these dogs. There's some variations as well for the species of the dogs. Cats, I think there's some variations in the species of the cats as well. So any kind of data set, we want to try and have variation so that the models can learn better. So if it's the exact same cat or the exact same color with the exact same species, then your model won't really have that generalization ability. So I have 6 samples of cats, 6 samples of dogs. So I'm going to train my model and I'm going to actually test it with my phone, an image of a cat from my phone, and then see how well does it work. So try and do the same on your computer as well. This might take some time, depending on how fast your internet is. Training. Okay, it's quite fast. Okay, so preview. So set your input to on. So if you so this model, okay, that was quite fast. So apparently the model has already been trained. Okay, so based on my image, it's saying that class 2. Okay, it's not. Okay, apparently I look more like a dog rather than a cat. Okay, no man. So just go to your phone, try and Google an image of a cat. Okay, and then we're going to just point that image of the cat here. So just go to Google Images. Okay, did I find a cat? Cat image. Can't find. Okay, this cat. Okay, so I have a picture of a cat here. Okay, and then we'll just see how well does the model work. Okay, so if you scroll here, okay. So if you see here, class 1 is going all the way to 100%. So that's correct. Okay, and then if I bring it a bit away, okay, when there's 2 images, the model gets a bit confused. Okay, now it's off my power saving mode. Okay, even though there's 2 images, my face and then the face of the cat, still if there's more cat, okay, you can see 99%, 96%. So the model actually is able to ignore my face and focus on the image of the cat. So let's say so class 1 appears to be recognized, okay, with only a training data of 6 images of the cat. We were able to recognize this by using a teachable machine. So let's say now I do dog image. Okay. images. Okay, and let's say I take, okay, German Shepherd. Okay, so let's say now I take this German Shepherd and I point it to the camera. Okay, so it's saying class 2. Okay, it's saying 99% or 100%. Okay, this is a dog. So if you see the benefit, or what I'm trying to illustrate is with only six images of dogs, and by using transfer learning, so probably maybe this is actually using Google Net or AlexNet or one of the pre-trained models. With only 6 sample images, we were actually able to recognize a cat or a dog. And if you notice just now, the training time was so short. It was a very short training time. So this is one of the example of a machine learning model of using this general pre-trained model, Google Net, AlexNet. There are some pre-trained models that are more specific. For example, there are pre-trained models that are more specific to recognize medical X-rays, to recognize voice, for example. So let's say now I want to use another model. Okay, another model. Let's say I use, cancel this. Let's say now I want to do pose estimation. Okay, I want to make use of, okay, pose estimation. So I have another data set, and then this pose estimation, this is actually making use of a pre-trained model that is more specific, that is more inclined towards pose estimation. So if you can go to pose project, okay, and then as for the samples, I have in the file I shared with you, I also have this pose data set, and then there are 2 categories, so peace and thumbs up. Okay, so peace, there is about how many images? There is about okay, 5. Okay, 5 images of thumbs up, and also 5 images of what's the second, thumbs up. Okay, so what I'm going to do is same like just now. The only difference is where our pre-trained model is something more domain specific. Okay, so if I go to class 1, let's say class 1 is going to be peace. Okay, I'm going to choose images. Okay, class 1. Okay, a small data set. Okay, this one, the pose data set. So let's say I start off with peace, and I upload all of these 5 images of the peace sign into this teachable machine learning model. Okay, loading samples. Taking time. Slow. Okay, next step. Okay, so 5 images only with V sign, victory sign, peace sign. And then second class, I'm going to upload all the thumbs up for images. So post data set and then thumbs up. Okay. All right. So I have 5 images of peace, 5 images of thumbs up. So we just train our model and see what happens. Not sure if it will work, but the main difference is this pre-trained model is more domain specific for pose estimation. I'll just train the model and see what happens. Okay. So these are all, basically there's 50 epochs. So if you go to advanced, you're going to see some parameters. So epochs, batch size, learning rate. Okay, learning rate is actually something that's related to, if you have heard about neural network. So back propagation. Okay, oh, so there's already finished training. That was fast. Okay, so now we already trained our machine learning model. So let's say if I show a peace sign, is it able to? Okay, how about if I show thumbs up? Okay, thumbs up 100%. So I have to kind of remove my face. Oh, I have to, okay, thumbs up. Okay, so pose, V sign. Yes. Okay. Okay, so maybe maybe needs more accuracy or maybe needs more data. Okay, so but that's roughly the idea of this transfer learning for post estimation. So I think if we have the time, so these other parameters, so I saying I'm measuring. Let's try again. This is the first one. How about thumbs up? Peace sign. Thumbs up. Peace sign again. Thumbs up. Okay, now my satisfied. Maybe because maybe the images that we have is not enough. So the background images are confusing the model. So apparently, like in this case, like I'm just showing my face. I don't have any V sign, but it's saying the model is confused. It's saying that I have a V sign. Maybe there's something about the shape of my face that the model thinks of, that it's similar to a V3 sign. If I move to the left a bit, thumbs up. Up. Camera. Okay. Erratic, not very stable. Okay, this now is right. Okay, so that is pretty much about teachable machine. So what's the a few more last things I want to share with you. So okay, so I just want to almost done. So I just want to tell you like what's actually happening behind the scenes. So all these pre-trained machine learning models, they're actually based on something called convolutional neural networks, or CNN. Okay, and then this CNN, okay, what it does, it has what we call layers basically. So these layers, we have basically two sets of layers. So what we need to know, all this transfer learning makes use of something called pre-trained models. There's a whole variety of these pre-trained models. There's GoogleNet, AlexNet, ResNet, and then in certain applications, there is also something called MobileNet. So there are some applications, for example, where you use a tab. For example, you want to develop an app, and then you want to, for example, some smartphone-related app, and then you want to utilize some machine learning models. So you would notice that all this GoogleNet, AlexNet, they work well on computers, but they don't really work well on mobile devices. So there are certain pre-trained models that work well on mobile devices, and one of it is known as MobileNet. Okay, but all of these pre-trained models, they're actually based on something called convolutional neural networks. And then these convolutional neural networks, they have two layers. We have like something called a general layer, and then we also have what you call a classification layer. Okay, and all these boxes that you see, these are all actually the what we call kernels. Okay, so basically, let's say if I have an image of an X-ray, and then I want the model to be able to classify, is this cancer, or is this a kind of tumor, is this pneumonia? So basically there is these boxes are going to actually slide through the image and then it's actually going to what we say extract features. So we have in a CNN, we have general features and we also have classification layers. Okay, those are the two main components. So what is actually being transferred in CNN, okay, or or how is transfer learning working when we are using CNN? So the layers, okay, we have the early layers in a CNN model, and then we also have the final layers. So the information from a previously trained model is actually being transferred to these earlier layers, or what we say the convolutional layers. Okay, so these first layers, they actually their job is to, we say, extract high level general features. Okay, what this means is that if, for example, we have an X-ray, the convolutional layers are actually detecting things like, okay, where is the bone, okay, where is the location of a sternum, for example, where is the location of the lung, for example. But those early layers, they are not actually responsible for actually determining, okay, is this a tumor or is this pneumonia. Information or differentiating between pneumonia and between cancer, between a tumor, that will actually be happening at the later layers, or we say the fully connected layers. These are the fully connected layers. But the earlier layers, where you have all these convolutional layers, all these kernels, they are extracting the high level features. High level features meaning they're not very specific. They're just detecting bones. They're just detecting the how the overall X-ray looks like, where are the lungs, but it's not really focusing on, okay, does this lung actually have cancer? Does it actually have pneumonia? This very specific differentiation is going to happen at the later layers. So in transfer learning, information from the previously trained machine learning models, they're actually being directly fed or directly in the convolutional layers. And then when you have some specific data, for example, you're a doctor, and then you really have some information that can differentiate between cancer and pneumonia, for example, in an Indian population. That information will actually be used to train the what we call the fully connected layer or the later layers of the convolutional neural network. So your data that you supply in just now's problem, for example, let's say you already have Google Net, you already have a pre-trained model that can differentiate dogs, but there are some specific dogs that are unique, or there are some specific cat species that are unique to India, and then you want to enhance Google Net, for example. That enhancement is going to actually happen in the later layers of the CNN, what we say, the fully connected layer. Okay, so what happens in CNN? Okay, almost done. What happens in CNN? Okay, we are actually freezing. Okay, we are freezing the CNN network weights. So let's say you have an object detection problem. And then you're using Google Net. So the CNN network weights, the first few layers are actually going to come from the pre-trained model. Then only your dense layers, we say, the later layers, that's only going the newer layers, that's going to come from you and your new set of data that you are introducing to the model. So for example, you already have a model that can recognize other languages, they can recognize English, but maybe how English is spoken in India, there is a dialect, for example, or there are some terms, for example. So you can actually use a previously trained model to recognize English, but then because of how English is spoken in India, there are some differences. That differences will actually happen or be used to develop the later layers of the CNN, this dense layer, what we call. Okay. So transfer learning. So okay. So just to wrap up. Okay. Why transfer learning is considered to be something that's crucial. So let's say we have a radiologist. Okay, and then this radiologist has a very large wealth of information. He has 30 years or maybe 40 years of experience in diagnosing diseases, in treating patients, in looking through X-rays. So let's say he wants to share his knowledge with the future generation of doctors, for example. So he can write books, or he can actually he can have videos, for example, but the transferring of the intelligence to the next generation, that cannot be done without AI. But let's say if, for example, based on his experience, his knowledge, his set of skills in analyzing X-rays, we use that knowledge to actually create a pre-trained model for future radiologists, then that is one way we can actually capture the intelligence of this very well or very highly experienced or world-renowned radiologists. Their experience can be captured in these AI models, this transfer learning. It can benefit students or later on those who are actually in the field. For example, even if the radiologist doesn't die, maybe if he retires, is no longer working, his intelligence can still be captured by these transfer learning models. Okay, so okay, about Elon Musk. Okay, so I think that's mainly what I wanted to present for today to all of you. So I would like to welcome if there are any questions from the floor, then before we pass to the next speaker. Okay, okay. There are already some exact questions. Very nice. So I'll just okay. I'll just answer. Okay, I'll just answer these questions. Sorry, I didn't notice earlier. Okay, okay, okay. Very interesting. Can this be integrated in students' projects? Definitely. Okay, depends on okay, what are you trying to achieve? Do you want to develop, let's say, some kind of robot? So if it's a robot, then you will also need to have that asset of embedded systems. So embedded systems, like just now in the Google teachable machine, there is a way you can actually train these models so that they are suitable to be implemented in embedded systems. So that can be a student project. So do we have pre-trained model for video input? I think there is. for video input, there is so even now, like if you have heard about YOLO, you only look once, YOLO. So now we have YOLO version 11. So YOLO version 11, you can actually use it to be put inside an autonomous car or autonomous vehicle, and it can recognize the surroundings. Okay, is there a car in front of me? Is there a lorry next to me? So there are actually pre-trained models for video input. So video input, I would recommend looking into YOLO, that whole object detection set of pre-trained models. So any models that recognize MRI X-rays, I think there are, but I forgot the name. So if you search on ChatGPT, there are some domain-specific pre-trained models for medical field. Okay, what models can be used for object detection in real time? This one I recommend using YOLO. YOLO, the latest YOLO is YOLO V11. Okay, is it customizable for multi? Okay, pre-trained model, it is customizable for multi-class. So the customization will happen in the dense layers, basically. So you have some new data that can enrich the pre-trained model. That it won't happen at the CNN early layers or the feature layers. That change or that modification or that optimization happens in the dense layers. Any pre-trained model for defect detection like crack and glaze. Okay, this one I have to look. Okay, so let's say if there is no specific pre-trained model to detect crack and glaze, even though if you actually use GoogleNet, for example, because GoogleNet, it kind of mimics human ability to perceive the surroundings. So even though there is no specific pre-trained model to detect cracks, even if you start off with GoogleNet or ResNet, one of these existing pre-trained models, because it's like you can think of it like a human. It's not entirely having zero intelligence. There are some intelligence. It is able to recognize a wall, for example, or it can recognize a road, for example. So you can actually fine-tune that pre-trained model to recognize cracks, but you need to have a data set for the kind of cracks that you are dealing with. So for anomaly detection in crowd video, what kind of pre-trained model will require which? Well, it's best for training and test. Okay, anomaly detection. What kind of pre-trained model will okay? If it's anomaly detection, you're probably YOLO. YOLO can be one option, but uh, crowd anomaly detection. Anomaly detection in machine learning is a field on its own. So maybe there might not be tools that can directly be used for anomaly detection in crowd, because crowd evacuation, crowd safety, this is one field. Crowd navigation is one field. There's even simulations that you can do using these certain softwares to simulate like a large crowd. So it's a field on its own. So I'm not sure if there's a pre-trained model specifically for crowd. Okay, for video data, which model will be so? Especially traffic sign detection. Okay, traffic sign detection. So there is another we call it field in machine learning. We call it OCR, or optical character recognition. So there is one library. So just to answer, there is one library actually by Google. It's called Tesseract. Tesseract is actually basically a pre-trained model to recognize words, to recognize sentences. So traffic signs. Okay, I think traffic sign there would already be a pre-trained model. Okay, to recognize traffic signs, because it's something very common. So the good thing about common problems, there would be already a pre-trained model, or some researcher already has previously a pre-trained model. We can actually take the weights of that model and use it in our application. So deepfake video, which pre-trained model? Okay. Okay, sometimes pre-trained model, when you say the best, it also depends on where you're going to apply it. Sorry, PPT not visible. Okay. So sometimes when you are talking about which is the best. So we also need to clarify what do we mean by the best? Do we mean accuracy, or do we mean that there won't be issues like lagging, or the recognition is slow, or things like latency? So one of the, if we say about best, if you want to implement on an app, for example, the best application for you is to implement the system on an app or mobile devices. Then MobileNet will be the best pre-trained model. Then, for example, if you have computational constraint is not an issue for you, then these models that have been trained on very large set of data, GoogleNet, then that will probably be the best for you. But sometimes there is no clear answer which is the best. Sometimes there is a bit of trial and error involved. Okay, for 9:30 already. So I think think it's 9:30 already. So I think I'll pass back to our organizers. So I'm very happy to share with you. I think the 160 participants. So it's really an honor for me to share. I hope you have learned something. So in our next session, we're going to cover about embedded systems. So I think I'll pass back to our organizer. Okay, thank you very much.